Okay, welcome back to CST 2120. So in this lecture I'm going to explain some advanced features of JavaScript which will hopefully enable you to write better code. So far in these lectures I've covered variables, functions, arrays, objects, events, and how to use JavaScript to interact with the document object model. In this lecture, I'm going to be covering sort of some advanced uses of functions. I'm going to get into classes, object-oriented JavaScript sort of more deeply, explain how you can use strict mode to prevent sort of silly pointless errors, and how you can use modules so you can sort of modularize your code and then sort of enable specific parts of that code to be used by other modules. If you use these advanced features of JavaScript, as well as other features of JavaScript, you can write code that's more compact, so less code, easier to maintain, easier to reuse, easier to scale up to larger systems. Because I can pretty much guarantee you're not going to write a large, complicated JavaScript application if you're using globally scoped variables and functions. Yeah, you want sort of modular, reusable code. Yeah. And at the end of the lecture, I'm going to illustrate how you can use most of these features, how you can put them all together by showing you how you can build a simple Space Invaders example. Yeah, so that's the plan. Okay, so first thing I want to cover is flexible functions. So in the previous examples, I've just shown you very basic function usage where you define the function and then you call the function. Yeah, so you've got a function here that's declared with some code inside, and then we call that function, like say hello Judy or something like that. Yeah. I've also explained how variables work. So variables can point to simple or complex data structures. So here we've got string variable, number variable, Boolean variable, a variable pointing to an object, and a variable pointing to an array. So variables can also point to functions. So this is a sort of deep thing in JavaScript, which it takes a little bit of time to get used to. So initially, I found this kind of tricky to grasp, if you like, because I'm used to kind of Java, where you've got, the variables, and then you've got the functions, and the two are sort of, separate, until death kind of thing. But in JavaScript, things are a bit more sort of free and easy. Yeah. So a variable can contain an integer, string, and a Boolean data type. I explained all about data types in the first lecture in JavaScript. And another type of data type is a function. Yeah. So you can have variables pointing to objects, and you can have variables pointing to functions. And that enables you to do lots of sort of slightly strange things with functions that you wouldn't be able to do in some other programming languages. So firstly, you can assign functions to variables. So if you've got a function here, say hello, whatever, then that function name, by saying let, can be assigned to another variable, yeah? So in this case, say hello is pointing to that sort of data structure in memory that holds the functional code. But I can also point hello function to that same function. And if I want to call that function using this variable, all I have to do is append the sort of smooth braces at the end of variable name. And because Java knows what data type that variable is, it knows it's a function, and therefore it can call that function when you request that by putting the smooth braces on. So behind the scenes, JavaScript's managing the data types, as I explained. It knows whether it's a string or a number or a Boolean. It knows the appropriate operations that can be carried out on each data type. And an operation that can be carried out on a function data type is to call that function, right? And that's why when we put the smooth braces on, we can call that function, and JavaScript will do that for you. We can also store anonymous functions and variables. So here I'm pointing a variable to a function that's sort of declared in a sort of traditional explicit way. But I can also, use the arrow or lambda notation to create a function and then assign that function to this variable here, yeah? And then call it in the same way by appending smooth braces to it. And this is exactly what we're doing when we're setting up event handlers. So I might have a function, my keyboard handler that does some kind of stuff on that. Now I'm doing this in a slightly laborious way, but just to make it clear. So here I've got a variable that's pointing to that function, and then I'm pointing the one window key on press to that variable. So in other words, what's really happening behind the scenes is we've got a single function in memory, this keyboard handler, and here I'm pointing function var to that point in memory, and then so I could have actually done window on key press equals keyboard handler, but I just put the intermediate stages to make it extremely explicit that these are just different pointers to the same function in memory. So this handler is being assigned to that function so that when window on key press occurs, they can just append braces to it somewhere in, you know, the browser sort of runtime engine and call that function sort of because I've assigned it to, because it's pointing that function when I set up the event handler. So variables can point to functions. We can include variables inside objects. So no surprise that functions can be included inside objects as well. And then the function can access other variables inside the object using this keyword, which I think I've covered in a previous lecture, yeah, in the object stuff. Yeah, so this is your sort of bog standard sort of JavaScript object containing some data. And here we've got an object that has a function inside it, yeah? So if I want to call that function's inside person, so I can call that function by doing person.sayHello, yeah? And when I do that inside the function, I'm calling using this.name, and that's to access the name that's inside this object. So if I just put name, it wouldn't recognize it, yeah, which is extremely irritating, as I'll mention later as well. But anyway, this is how JavaScript works. To access name inside the same object that the function's inside, I just do this.name, and that enables me to access Susan, in this case, the name Susan. And so the output when it says say hello is hello, I am Susan, yeah? If the function was inside a different object with name set to John or something, then it'd be saying, hello, I am John. Since functions are variables can be stored in arrays, so functions can be stored in arrays. Unlikely, I've never had to store functions in arrays, but you never know. It's worth considering maybe at some point. So here we've got an array of functions instead of like strings or numbers or whatever, or objects. We've actually just got functions in the array, right? And so to call those functions, it's exactly like the other earlier examples. First, we reference the particular position in the array using the index. So this is 0, 1, and 2. And then to call the function, we append the braces, right? The smooth braces. And that enables us to call the function. And so we get hello, David, hello, Tim, hello, Titania, yeah? And it tells us we're calling the different functions in the array because I put these strings in just to make that clear, yeah? Again, anything we can do with variables, we can do with functions, because functions are just a variable type, so we can pass variables as arguments to functions, and so we can pass functions as arguments to functions, right? So here we've got a function that calls another function. The argument of this function, caller function, is itself a function. Yeah, it gets a little confusing. So it's just like, you know, a sort of semi-fun example. So when we call this method, this function here, we pass in as an argument to that another function, yeah? So I'm calling say hello here, I'm passing say hello as the argument into this function caller. And then to call a function, you just append the smooth braces, so then an argument with the smooth braces, I then can call say hello after I passed it into that function. And of course we can return functions from functions as well, yeah? So here we're creating a function, could have just done an enormous one, but I'm trying to be explicit here. Creating a function inside this function, and you also have this passing of functions into functions actually happens a lot when you're doing kind of callbacks, yeah? So you might have a kind of complicated, this kind of stuff actually does happen all the time. When you have an operation that might take a long time, and you pass a function into the call to start the long operation, and then when the operation's finished, that function gets called and then does something else when the operation's over. So in terms of callbacks, this stuff's used a lot, yeah? But anyway, let's move on this. So we can have a function that can be returned from a function, so creating the function and returning it. So we call this create function function, which returns a function, which I'm storing here, and then I can call the function by appending, you know, the smooth braces to it in the standard way, yeah? And since functions are variables, we can compare them too, but it's not terribly smart. So really the only one that makes any sense is the sort of triple equals, which returns true if variables are pointing to the same function. So here I've got two functions, got say hello 1 and say hello 2. Now these are functionally equivalent. So you'd sort of think that JavaScript could do something clever and say, well, these two functions do the same thing, therefore they're the same. But because what JavaScript will compare is not the function themselves, it'll compare the it's whether the two variables are pointing to the same function. So say hello is the name of this function, it's pointing to one part of memory. Say hello 2 is pointing to another part of memory. So actually they're not pointing to the same thing. So the only thing that's pointing to the same thing is this hello pointer, which I've assigned to say hello1. So say hello1 is this function here. Now this is pointing to the same function, so this is the same, but say hello1 and say hello2 are not the same. So if we compare say hello1 and say hello2 with a double equals or triple equals, that always returns false. But if we compare hello pointer to say hello1, because they're both pointing to exactly the same function in the same place in memory, that's going to return true. Something to be aware when you're working with functions is that the browser makes two passes through the JavaScript when it's executing it. Yeah. So the first part, it looks for explicitly defined functions. That means functions defined with the keyword function. Yeah. And then once it's found all the keyword functions to declare defined with function, then it will execute the code. So if the function's explicitly defined using the function keyword, then we can call it anywhere in the code. So in this case, this will work. Yeah. Because according say hello. Even though this piece of code comes before here, because it's already done one part, this on the second pass through the code, the browser will be trying to execute the stuff. So come to here, in the first pass it identified the say hello function, so then it can actually execute it here. Yeah, so that will work, yeah? But functions that are assigned to variables when they're created can only be called after they've been created. So JavaScript doesn't sort of execute all the code twice, right? It only does it once, but it does do a pass through to identify functions. But it's not executing code, so it's not going to execute this assignment thing, which is kind of creating this function, kind of this anonymous function. So if I call my function before this bit of code's been executed, before this is not going to work, yeah? If you're using anonymous functions and storing them in variables like this, you need to call them after they've been created in the variable, after the variable's been assigned and all that kind of stuff. So this will work, this will not work, yeah? But it will work if you're actually using the function keyword, you know, as explained here. Okay, so this that wasn't meant to be a sort of detailed thing that will really help you, you know, understand everything there is to know about functions. So, excuse me. I went through the function stuff to show you that functions are a kind of variable, and anything you can do with a variable you can do with a function in JavaScript. So that's the message I'm trying to get home with you here. You may or may not need to do some or all of the things that I've explained there, and I'm not going to, you know, drill you with examples because there's other more important features of JavaScript I want to cover, yeah? But don't be surprised when you see that kind of code, and maybe it'll trigger a memory and you can go back and look it up some more, yeah? Okay, so let's go into classes, yeah? So when I learned, you know, programming quite a long time ago now, you know, I had these sort of very tedious lectures on object-oriented programming, yeah, and you know, it was a good teacher, right? But it kind of, you know, just put up the usual sort of here's a shape and here's a rectangle that extends shape, and it was all very abstract and all very boring, yeah. But when you actually start writing larger projects, then you'll find that object-oriented programming is extremely useful. Yeah, so initially it just seems like this sort of hostile alien thing that's thrust upon you as an undergraduate. You just got to soak it up somehow and reproduce it in the exam. But actually, object-oriented programming is fantastic, and it's much easier to work with than just endless functions and global variables. Yeah. You can break problems down more easily, create objects that correspond to objects in the real world, add behaviors to objects that correspond to behaviors objects in the real world. You can simplify programming, you can write less code, and because it's got this kind of encapsulation, you're wrapping up code in objects, that enables you to write much more complicated code, much bigger systems, yeah, with less errors in them, yeah. So object-oriented programming has its critics, and you can write big code without it. I think Linux kernel, you know, it's in C, right, not C++. And C is not object-oriented. So you can write big systems without it, but if you want to write big systems, you'd be strongly recommended to use object-oriented programming, in my opinion, yeah? Other people might disagree. I love it, you know. Okay, so I've explained how in JavaScript you can combine properties and functions inside objects, yeah? So this is a sort of, you know, here's the properties of the object, the name, age, the hair color, the height, and then we've got a function inside the object, and then we can call that function, you know, by doing .sayHello kind of thing, yeah? But with this kind of object approach, we're just kind of creating an object sort of on the fly, so to speak. You know, and if we want two objects, this is one person, right? But if we want two people, we've got to do let Jack equals, and then have all the names and properties of Jack. And then we've got to do the same thing with Susan. So obviously that's kind of messy and a lot of duplication of code, particularly the functions, right? I've got to kind of copy and paste this. Suppose we wanted to do some kind of city simulation with a million people. It's going to take an awful lot of code to write, and we're going to get an awful lot of errors. And not only that, but we're going to need to, if we make a change to the person object, then we're going to have to change all of our code, and it's going to be, a sort of hellish mess. Yeah, so obviously this way of creating objects is not sustainable. We need something better. Now, earlier versions of JavaScript had this prototype support for object-oriented programming. No doubt it has its fans, but I have to say I absolutely hated it. You can probably find an old lecture, the previous version of this lecture I recorded for this module, in which I had at least half of it was on prototypes. I think they're absolutely nightmarish, horrible, hacky things to work with, but other people, they may have their fans, heaven knows, yeah? It's a broad world and all that, yeah? But modern JavaScript, fortunately, has moved beyond prototypes and has classes, which have their limitations. I'm not a committed fan, but they're much better, yeah? Much better than prototypes, much better than objects. So JavaScript classes have constructors, inheritance, private methods and properties, and static methods and properties, yeah? So to create classes in JavaScript, there's a few sort of basic rules. You capitalize the first letter in a class name. That's standard. So it's not enforced by the language, but it's something you should stick to as a convention. There's no commas between class methods, semicolon after class variables, and use the constructor keyword. Yeah, so that's probably easier with an example than this kind of abstract stuff. So let's go through a class. Yeah. So here we've got a class animal. So we've got the class keyword, and then we've got animal, which is a capital by convention. This class can have any number of properties, and instead of the colon, which you have an object, you have an equals, and you can assign a sort of default value to a class property, like anonymous, in this case being assigned to name. You can obviously override it later, and then age doesn't have any default properties associated with it. Classes have a constructor. I mean, you don't have to include one, but they're usually handy. And so here we're passing in some variables as arguments, and then we're setting up and copying these into the class properties. And then we got some methods in the class, like increase age and toString. We don't have to say function or any of that. It's sort of, because it's inside a class, JavaScript knows that this is a class method. Yeah. Now this is the bit I hate about classes. I loathe this about classes. I don't know why they have it in JavaScript. Yeah, but every single time you want to refer to a property of a class, you have to use this, yeah? So in Java, it does proper sort of, scope handling in the sense that if you say this here, if you say age here, for example, it knows it refers to age because it can find it inside the class. But with JavaScript, it doesn't. And so you're endlessly forgetting to put this in front of a class name if you're used to Java, yeah? In front of a class property, yeah? So, this.age, this.name, it's just unnecessary, annoying typing, yeah? But there's nothing you do about it. Maybe they'll fix it in some later version of the language, yeah? So whenever you need to refer to a property of a class inside a class, you have to use this, yeah? So to use this class, let's, go through an example. So to create a new instance of that class, so this is just a declaration of a type of object, if you like. To create an actual, instance of that object, with the data that you can change and all that, we have to use the new keyword. And then this passes in the objects, the name and the age into the constructor, which are then used to set up an animal object. And then that's assigned into this variable dog. So we're creating two animal objects, which are being assigned to dog and cat. Once they exist, we can do things like increase age and, log out the dog to string, that kind of stuff. Now, this is sort of going back to my early days, learning object-oriented programming. So you often see in the introductory lectures to this stuff, this sort of inheritance stuff. Yeah, that, as I said, the extremely dull example of a shape that is then extended by, a rectangle and all the rest of it. Yeah. So in a lot of code that you're just creating from scratch for yourself, you rarely use inheritance. I mean, inheritance isn't necessarily an obvious thing you're going to use in a program that's mostly got your own code in it. Yeah. Obviously in Java you're constantly extending things and overriding their properties, but in a lot of other areas you don't necessarily need inheritance. But you will find that there are some areas where inheritance will work beautifully for you and makes a lot of sense. So it is worth learning about it because sometimes it'll be very useful, even in JavaScript, yeah? And my Space Invaders example at the end uses inheritance because it just makes sense in that context, yeah? So with inheritance, you can extend a new class, and you can override existing methods, you can add new properties and methods, but you still have access to all of the methods and constructor and all that rest of it in the parent object, the parent class. You can just use the super keyword to access stuff in the parent class, yeah? So again, I think I'll just go through the example, yeah? So suppose we want the animal class is a bit generic. There are maybe perhaps some things that are specific to dogs. So instead of modifying our animal class to include all of the possible properties of all the possible animals, it makes more sense to extend the animal class with like a dog class and a cat class and a beetle class if beetles are animals. So in this case, dogs supposedly have a sort of human year equivalent age, right? So it's like 7 times or whatever it is, so that you can kind of calculate how near the dog is to death kind of thing. And maybe the dog has some specific food. This is kind of a bit made up, yeah? So the dog class has its own kind of constructor. You can write your own constructor. And I can, within that constructor, I can call the constructor of the animal class, yeah? So I'm passing in name and age. So there's some, so why not just call the super class to initialize the name and the age, yeah? So I don't have to mess about with that. And then after that, I can then do this specific stuff for dogs, like initializing age human years to 7 times the actual biological age. Then again, I've got a couple of methods here that are overriding the methods that are in the animal class. So animal has an increase age, animal has a toString method. But in these overridden methods, I'm still making use of what exists in the animal class because I'm calling super increase age. So I'm increasing the animal's biological age, but then I'm doing my own thing here by increasing the age in human years, like by 7 times this age. And here I'm combining the super toString method with some other strings that are specific to dogs, yeah? So I'm using what's the code that exists already in animal, but then I'm extending it in very specific ways so that my dog is kind of customized to be the specific kind of animal that a dog is, yeah? And then to use that, again, I just use new dog, and then I can use increase age to string, etc. Yeah. Right. So let's do a little demo of that. Yeah. Okay. So let's start with, where's my demo gone? Yep. Here we go. Yep. So I'm gonna, follow the long and honourable tradition of the death-defyingly dull, daringly dull, you might say, shape stuff. Yeah. So let's do class shape. Yeah. So each shape has an X position, a Y position, and let's say width and a height, yeah? Okay, so these are the, we could have defaults on here if we have height equals 3, but it really doesn't make any sense in the context of a shape. And then we're going to have a constructor, let's say. Right, and the constructor we're going to pass in X pos, Y pos, width, and the height. Okay, so with the constructor, we usually want to store these things as the sort of setup initial properties of the shape. Yeah, so we have this dot xpos, this dot y, width, this dot height. Okay, so we store these things within the shape, and in terms of shape we don't need much, and then we're probably going to have something like a draw method, let's say, yeah? And I'm not going to write the details of this because, heaven knows how it's going to be drawn, but anyway, draw shape, yeah? A bit of a mixture of model and view, but never mind, let's just roll with it, yeah? So we've got a shape class here, yeah? Now, obviously, we also might have kinds of shapes that have things that are specific to them, and these specific things might not be captured by our generic shape class, but they still have all the properties of a shape class as well. So the classic thing here is a circle, yeah? So we have a circle class here. Now circles have something very specific to circles that you don't have in just every shape, yeah, which is a radius, yeah? So we're going to have the radius, yeah? And then the constructor of the circle class, so circles still have an X position, right? They still have a Y position. To some extent, width and height makes some kind of sense. Oh no, well, sorry, they don't make sense, yeah. But we will have radius, yeah. So if we're constructing a new circle, that's the kind of stuff we want to provide for our new circle. We still can make use of the superclass. So we can still call the superclass constructor here. So this super here is calling this superclass constructor here, yeah. So xpos, ypos, And in case of in this case, the width and height is 2 times the radius, isn't it? Yep, 2 times radius, 2 times radius. So calling the superclass, and then we're storing radius in our circle method here, yeah? Equals. Okay, so we're using the superclass because the circle still has an x position, y position, width, and a height, but it also has the specific thing that's not shared by all shapes, which is the radius, yeah? And then we might have a draw method here. Similar kind of idea, right? So we might call super.draw, and then we might do some specific circle things, yeah? Or we might just use our own. So probably wouldn't do super.draw because drawing a shape, a square and a circle is very different, but we do specific circle things, let's say, yeah, you know, like drawing a circle, yeah? So I hope you can see this little example. We've got our sort of superclass, our sort of, you know, generic shape class with a bunch of features, and we're using these features. We're not just copying shape into as circle because we're saving ourselves some code because all this stuff is still being handled by shape. We might also have an intersect method that we could use in circle, for example. But then we're adding some extra stuff that's specific to circles, yeah? And that's true of all this kind of, you know, inheritance kind of thing. Okay, so create a class, inheritance, that's all good, yep. All right. So when you work with Java, you get very used to kind of public, protected, and private. And you want private variables. Again, it's this encapsulation, the wrapping up of code within an object so that other objects can't mess with it in inappropriate ways, yeah? So if you want to make variables private within JavaScript classes, you can do that using the kind of hash before the variable, yeah? And a private variable can only be accessed within a class unless you added like a getter and a setter method to the class. Note this is a recent addition to the language, so Visual Studio Code doesn't recognize it, flags it up as an error. Some browsers probably won't work with it, but modern Chrome, 72 onwards I think it is, works fine with it, yeah? So just to show you, yeah, so here we've got a class person. I'm using the hash here for weight to show that weight is a private variable, yeah? So if I do console log person hash.hash weight, generates an error. The browser doesn't recognize that as an error. Visual Studio Code thinks it's an error anyway because it doesn't understand hash, but the browser, which does understand hash, would generate an error if I do that, yeah? On the other hand, if I do person.print, and in this case, this .hash weight is being accessed from inside the class, then that won't generate an error and it'll output 50, you know, which is the weight, yeah? So you can. It's slightly annoying that you probably can fix Visual Studio Code to work with the latest version of JavaScript or with these you know, beta features or whatever. So it's slightly annoying it doesn't recognize it, and you probably won't need it anyway. But just to be aware, if you want to create private variables, you know, in a year, let's say Visual Studio Code will recognize it out of the box, and it's probably quite a useful feature to have. Yeah. And finally, if you're working with classes, sometimes it's useful to know whether an object is an instance of a particular class, and you've got this keyword instance of to tell you what class and whether that's true or not. Yeah, so in this case, Andrew is a dog, which I'm showing you making, but the dog's there somewhere. Andrew equals new dog, or something like that. And so we do Andrew instance of dog. It'll return true if Andrew is an instance of a dog. Yeah. Okay. Right. So hopefully that's enough of an introduction to classes, yeah? And when you start using them, I hope you'll see just how beautiful and easy they are to work with, apart from the this keyword thing, which I find stupidly annoying, yeah? Okay, so let's talk about strict mode. So early versions of JavaScript, pretty free and easy, yeah? You know, you could sort of do all kinds of bad programming practices and get away with them, yeah? And most of the time your code worked, but then when you had a bug, it was often nightmarishly difficult to find out where that bug came from, particularly when you've got, you know, complicated code. So in these early versions, you could use variables without declaring them, delete variables and functions, duplicate parameter names and function arguments, write to read-only properties. You could do basically a load of things that led to sloppy, insecure, unreliable code that was difficult to debug. Yeah, in some function you might overwrite some global variable, or you might, you know, which you weren't really aware of just because you missed out the var keyword somewhere or other. It was, you know, JavaScript has a little bit of a bad reputation, and part of the bad reputation comes from, you know, these kind of things that you used to be able to do in it. Yeah. People recognize these problems, and introduced new features and restrictions on what you can do with JavaScript to improve code quality. So to maintain backwards compatibility, these features are disabled by default, but you can enable them with this kind of use strict directive. Yeah. So the idea is you place use strict at the top of the script or at the beginning of a function, and then all the code that comes after use strict, as long as it's at the top, you can't put it halfway down and then hope it will interpret after that. It has to cover the entire function or the entire code or nothing. So if it's at the top of the entire code base, the entire code in your page, then all the code in the page will be interpreted using these stricter rules, which will enable you to produce better JavaScript. Yeah, and if you've got problems with doing the whole page, shouldn't have, but if you did for some weird reason, then you could just make it local, the strictness local to a particular function or several functions if you want it. Supported by modern browsers, and quite frankly, your code should always run in strict mode, so just make a habit of writing use strict to the top of your JavaScript. So these are the rules of use strict. Yeah, you can't use variables without declaring them. You know, these rules you should never do this stuff anyway, but this will mean that it's actually checked rather than just sort of implicit. So you can't use variables without declaring them. You can't delete variables and functions. Function arguments must have unique names. Can't write to read-only properties, and you can't call your variables silly names. And they've reserved some names for the future use of JavaScript that aren't in the current language, but may be used in the future, like package, for example. Maybe they're going to add that later. So you can't call, your variable name package, because then it's going to break at some point when you try and run it on a more recent version of JavaScript. Okay, so to use strict, you just put it there, and then it'll apply to all of your code. You can't put it here because that'll be too late. It has to be at the start of the code. But if you want it to be just local to the function, the strictness, then you can put it at the beginning of a function instead. But this is the best place to put it. Yeah. So let's go through a demo with this. Yeah, because I think it's I'm listed all this stuff, but it's really not really not so clear. Yeah. So here's my demo. Yeah. So what I'm going to do, or try to do, is move this up to the top. Okay, to there, and then we should be able to see. Yeah, we should be able to see the debugging stuff at the bottom there. Yeah, that's good. Yeah, okay. Okay, so we've got live server running, so any changes I save here should appear there. Yeah, so I've got use strict to the top here. So what if we use the variable without declaring it? Yeah, and then here the browser's picking up as an error. So because reference x is not defined. Yeah, so if we do let x equals, that's fine, that fixes it as you'd expect. And in the older version of JavaScript without strictness, you could just get away with this kind of sloppy programming, and then this wouldn't be an error either. But if you put use strict back on and save it, then we get that error. Yeah. So hopefully you're not going to do that, but to make sure you don't, use the use strict directive. Yeah. You're not allowed to delete variables, kind of a pretty pointless thing to do anyway, I thought. But anyway, if you try and delete variables, you get syntax error. Same thing with deleting functions. Create a function, then try and delete it. Again, we get the same problem here. Yeah. We're not allowed now. This again, you should never do, but just you could just about work with duplicate parameter names because you get kind of function arguments which is like an array, and then you could work with that array, and then you could just about make that work. But you'd be crazy to try to do so. So you should never have duplicate parameter names in your functions. So again, use strict will check it, because believe it or not, in earlier versions of JavaScript you get away with that. Yeah, if I disable it, then you don't get the error message. But should never do it, obviously. Now this is a little bit subtle and complicated. I always find this can be pretty confusing. Okay, so let's just try and explain this. So in previous, let's do it without use strict to start with. Yeah. So we've got let's just maximize the clarity here. So when we're calling a function, then this will refer to the object. Wait a minute. Yeah. So this refers, without strict mode, this refers to the context, the entire window in which the context in which the function's called. Yeah. So if I call console.log this, I'm calling a function that's just sort of inside the window. So this refers to the window as a whole. Yeah. So if I'm logging out the this object of this function when I'm calling it here. So I've got a function, I'm calling it here, and I'm logging out the object, the this, that corresponds to that function. Yeah, in this case, it's turns out to be the window as a whole, yeah? So if I put use strict on, then this is undefined, yeah? Which is better, yeah, because what's with the strict mode, what this means instead is that this will refer to the object that called the function, and if no object has called that function, then it just is undefined, yeah? So without use strict mode, this refers to the window when you just call a function, you know, anywhere inside, you know, global scope, let's say. Whereas if we enable strict mode, then this inside a function will only come up with something meaningful if it's called by a particular object, in which case it refers to the object. So if we create an object here, and inside that object we put a variable, that property that points to that function, yeah, and then we call that function. So in this case, the function, the same function, I'm just pointing to it from within an object. So in this case, I'm calling that function within an object, and so in this case, if I save that, the first case it's undefined because it's just being called in kind of global scope, and there's no point in having this revert the window. But usefully in this case, this refers to the object that called it. Yeah. So in this case, it makes sense. Yeah. This dot. Let's just do console log this dot, you know, name, for example. Yeah. So in this case, this is a sort of useful thing, right? Wait a minute. Yep. Let's get rid of that. Yeah, there we go. Yeah. So because we're calling it from inside an object, it makes sense to use this because this refers to the object, and we can use this to access properties of the object. Whereas if we just call it in global scope, it doesn't really make any sense. We can just use window if we wanted to access the window object. Yeah. I realize that's not necessarily the clearest thing on earth, but you know, it's something I can't, you know, I have to have a whole lecture on this, and then we could really get into this. Yeah. Okay, so finally, got restrictions on variable names. So if you don't call your variables public or, you know, package or anything like that, yeah, it'll prevent you from doing silly things like that. Yep. Okay. So as a general rule, enable strict mode by putting that at the top of your code, and it'll reduce the number of errors that you make. Next thing I want to cover is modules. Okay, which I obviously want to. Now, if you're writing, you know, a simple registration login system with a couple of hundred lines of JavaScript, let's say, then you know, you don't need to worry too much about modules. But modern JavaScript applications are big, yeah. I mean, I imagine there's like ones with tens of thousands of lines of code out there now, and you couldn't possibly have those tens of thousands of lines of code in a single file. Yeah, it'd be impossible to maintain. It would be just, you know, you doubt whether your IDE would handle it very well either. You spend most of your life searching through, you know, large amounts of code. So a couple of years ago, when I was last running this module, you know, some students, you know, wrote some pretty impressive games. They had, like, you know, versions of Tetris and, you know, sort of some kind of Chicken Road kind of stuff. And some of these games are taking up 1,000 lines of code, and it was, you know, students spending quite a long time fishing around in that code to make improvements and change them because the code was so long. Yeah. So in general, if you're getting to that stage of more than 500 lines of code, let's say, it's much better to split your JavaScript into multiple files, and it makes it easier to understand and maintain. And rather than just splitting it into files, it's better to kind of split it into different modules, because JavaScript has support for modules. And again, modules has this kind of encapsulation feature, so you can use a variable name in one module and in a different module in a different way, without the names clashing or interfering with each other. So if I have like X used in one module, one file, let's say, even if it's global scope within the module, I won't be able to access it within a different module unless I explicitly export it and import it. So it gives you this, enables two people to collaborate on a project without coordinating every single variable name that they're using in name of function. So if you're using a script in the browser that uses modules, you have to declare that it's a type module. That will allow us to import other modules into that script. And then we can also create separate JavaScript files that contain code, and then we can use export to specify which variables and functions should be accessible outside that file. And anything that's not exported remains private within the file, but can still be used by code within the file. Yeah. And then in the other code, we can then use import to import variables and methods from another file. Yes, again, examples are probably better here. Yeah. So here we've got our file. I forgot what it's called, probably export.js or something like that. So inside here, we've got variables that can only be accessed from inside the file because they're not exported. They're just standard plain old variables, and any other file won't be able to access them. Yeah. Then we've also got a couple of variables and a function that are exported, and because they're exported, we'll be able to use them elsewhere. Yeah. So this is like a simple string variable, an object, and a function. Now note about this function. This function is using variables that exist within the file. So this one can access Tony name because it's in the same file as Tony name, but Tony name can't be accessed by anything outside it. So I can call this list people from outside this module, but I can't access Tony name. But the list people can access other things within this same file. So let's try and use these things. So we have script type module. We have to put that at the top. And then we can import the things that we've exported from these other files. So I've got this export demo, that's what I called it. So I can import Susan name, Susan object, and list people from there. And then I can just use these things in my code. I can use Susan name, Susan object, and I can call list people. So list people is an exported function, so I can call it. And that exported function has access to other things, other properties and variables within that same file. So even though I can't access Tony name, this function can, and it can display it to the user. Okay, so let's do a little demo. So let's do the same thing I tried to do last time. So that's my module demo. Okay, so this is my exporting. Okay, so Tony name and Tony object are both local to that module, whereas Susan name, Susan object, and this other stuff is. And if I find my module demo, so this stuff all works fine. That's what we're seeing somewhere in the code there with a bit of luck. Let's just pull that down, pull that up. Yep. So this is what's happening here. Yeah. And then if I try and import these things, right, doesn't work. Yeah, because Tony name and Tony object aren't exported, so I can't import them. Yeah, it doesn't get the error. Does not provide an export name Tony name. Or if I try and do, these things just don't exist, right? So if I tried to access, Tony name or something like that, then, I'm going to get Tony name's not defined, yeah? So only the stuff that's exported, I can only import stuff that's been exported, yeah? And that's nice, that's just what you want, yeah? Okay, so to wrap it up, I thought it'd be fun to sort of show you a sort of complete application, or semi-complete, should we say, an example that puts together the classes, modules, and the strict mode. I haven't got fancy function stuff, but never mind. Yeah, another day. Yeah. So I put together a simple example to illustrate some of these advanced features of JavaScript. I'll provide the code at the end so you can have a look through it and have a play with it, maybe adapt it for your own purposes. Yeah. So this is a very, very basic form of Space Invaders. Yeah. So let's just play the game such as it is. So here we've got our sort of alien who's sort of moving around in this unpredictable alien kind of pattern. And here we've got our rocket. And we've got a keyboard handler. So when I press on the space bar, it fires the rocket, yeah? And if the rocket hits the alien, then, game over, yeah? So I can miss the alien. Try and miss the alien again. Yeah, it's not got very good collision detection because, so if I try and miss the alien, let's try and hit the alien now. There we go. So when it hits the alien, roughly, then the alien explodes, and that's it. So obviously, this isn't perhaps the most politically or correct version of Space Invaders these days. We'd welcome the aliens, and we'd learn much from each other's cultures and all that kind of stuff. It's a bit old school, but never mind. Yeah. Okay, so let's look at the code, which is kind of the purpose of this, really. Right. So I'm using classes. And classes make a huge amount of sense here. So, if you're doing this kind of thing, you might find the classes help you, yeah? So what I've got is a generic kind of spaceship class, yeah? Which has a position, it can draw an image corresponding to that spaceship, and it has a contains property to tell if one spaceship intersects with another spaceship, yeah? So, and then on top of that, then I've got an alien spaceship. Now the alien if you look at the demo, right? The aliens, let's go back, yeah, so the alien, let's go back to the demo actually. So if you look at this thing, yeah, so each of these classes is doing different things. So this is my spaceship class here, yeah. All it does is sit there, yeah. Not a lot, yeah. And then the alien's sort of moving around, yeah. It's got sort of one kind of behavior, yeah. And then I've also got a missile, which is kind of a type of spaceship, as well, and but this missile does one thing, it kind of moves up the page. So I'm using object-oriented sort of programming here to have a sort of generic spaceship with some generic draw stuff in it, and then I'm extending that in my alien spaceship and adding the sort of movement of the alien stuff to that. And I'm also extending the spaceship class in my missile class with the kind of missile functionality of like moving up the page, yeah, and the sort of in the air launching and that kind of stuff, yeah. So it's, in this case, object-oriented programming is sort of saving me a lot of hassle, yeah. So at the beginning, I've got a class spaceship which I'm exporting so I can use it in other modules. Then I've got a bunch of sort of properties of this spaceship class, like an image, which is a sort of HTML image, the context, which I used to draw it on the canvas, and an X position, Y position. And the constructor is just sort of copying this, you know, this stuff into the class. But significantly, because I haven't covered this earlier, it's also creating a new image and storing and using image.source to point to the path of the image. So this is how, so drawing on the canvas, you need to, if you want to draw an image on the canvas, which you might have to do, then you need to create an image object and then set the source property to the path of the image object. You can also create an image object from an image that's already in the browser, like already sort of in the HTML somewhere, but that's a bit crude. This is better, but then this may have some bugs with loading of the images, and I did have these kind of problems when I was writing this. It seems to work now, but you know, if you're doing this properly, you might want to wait for the images to load or something, or preload the images somehow, yeah? But it kind of works, but it may be buggy, particularly if it's working over a network. And to draw the image, this is the context draw image method. It's pretty easy. You just, as long as the image is correct and is loaded, then as long as it's the right size, you just specify the X and the Y position. So these are the methods of my spaceship objects: draw and contains, which is a sort of slightly crude method for telling whether one spaceship is inside another spaceship method, yeah? As you saw, it doesn't work perfectly, but it's kind of good enough, yeah? Right, so that's my generic, my sort of superclass, if you like, which I also use just straight as is for those sort of human rocket, yeah? Then I've got my alien spaceship. So this alien spaceship is extending spaceship class, and so since it's extending the spaceship class, it needs to be able to access it, and so I have to import it from spaceship so I can use it. Then I've got it, and then I'm exporting it so I can use it elsewhere in my main code. And then I've got the sort of stuff that's specific to the alien spaceship. Remember, it's got that wobble thing. The wobble, the sort of movement left to right doesn't occur all the time. It occurs like a fixed after every 10 time steps, something like that. And then it's got like a starting position, because the wobble is relative to the sort of center position. It should be kind of center position, probably make more sense. Anyway, so we've got a constructor that sets that up. So it sets up the stuff that's generic to spaceship using the super constructor of the spaceship class. And then it's got some specific things specific to the alien spaceship that it needs to initialize. And the alien spaceship has its own kind of, every time the draw method's called as part of the animation, it does the calculation about whether it's moves left or right or stuff. That's specific to the alien spaceship. None of the other spacecraft do that. And then it's got the generic stuff to draw the actual spacecraft on the canvas, which it calls in the superclass. Missile works roughly the same way. We're extending spaceship and we're importing the spaceship class so we can use it. We're exporting it. Then the missile has a method unique to missiles, right? Launch, so it can be fired up into the air. And then the draw method works much the same as the alien spaceship method. It does the missile specific things, and then it kind of calls the superclass to do the actual drawing. Now we can actually talk about the game itself. Using canvases here. It's not CSS animation. So I'm need to declare that the script's a type of module, so I can import other modules. I'm using strict to get extra checks on my JavaScript. Then I'm importing spaceship, the classes here, spaceship, alien spaceship, and missile here. Then I've got some global variables, which is a little bit sloppy, but you know, I can live with it. Then when the window loads, it calls this initialization method. Initialization method sets up the new spaceships. So actually, I was using this initialization thing to deal with the problem of images loading, but thinking about this is not going to work. I should probably have a I should really just do, when we do some kind of initialization thing that loads up the images and then triggers the initialization method, but never mind, it'll do, it works for the moment. So what we're doing here is creating new instances of the spaceship, the alien spaceship, and the missile classes, yeah? Then we've got the, we're listening for keyboard events, right? So when we press on the space bar, it calls the missile launch method to kind of launch the missile up, yeah? And then we've got it's an animated thing, right? So we need to set an interval, a timer. So it's going to call the draw method, in this case, every 100 milliseconds. So draw methods, just like the other animation examples I gave you, we're going to clear the canvas. And then again, if we want to make this better, we could do some kind of space background. And then we draw the missile, draw the spaceship, draw the alien spaceship. And then to actually have some kind of game functionality, we're going to check if the alien spaceship contains the missile. It's using the spaceship code. Obviously, if the missiles hit the alien spaceship, then that's the game's over. And then we draw a big red message. If we're doing a better job, we'd have some kind of explosion effect, something like that, yeah? So obviously, this is deeply lame game. But what I wanted to show you is, how you can write sort of nice game code in an object-oriented way using modules, yeah? So if we look at, let's just quickly fish out the code for this, yeah? So if you look at the code here, we've got our space game here, and then we've got the JavaScript with the alien spaceship, the missile, and that, and we've got our images. So files are the organization of files, there's marks for that, yeah? And then if you look at the actual code itself, I think it's pretty nice and clean, yeah? We've got our kind of space game. As I said, it could definitely be improved. There's better ways of writing this code, but it's only an example. So it's sort of nice, clean code, and then we've got our sort of our classes here. Not that, but this and this, which we're kind of importing. So it's nice, modular, well laid out, tidy. It's a good way to write code, I think. That's the main purpose of showing you this, not the very specific details of the implementation, which could obviously be improved, yeah? So obviously you could have multiple aliens. Obviously the aliens could fight back. They can just be some kind of turkey shoot, massacre the aliens kind of thing. Obviously it'd be better if the rocket can move it as well. That's the classic Space Invaders. You could use sprite sheets to do some kind of explosion effect. Scrolling space backgrounds, it looks like the spaceship's moving through space. Multiple levels and so on and so forth, yeah? It's only an illustration. I've given you these example codes so you can see how you can stitch together different modules and classes into a project. You're welcome to adapt this for your coursework, but obviously you only need to gain credit for modifications that you make. So if you hand in this Space Invaders as your project for your game, you're going to get 0 out of 15 for it, yeah? Because I've just written it for you, yeah? But if you kind of add all that cool stuff, yeah, then we can, have a conversation about, then you're going to get at least 5 and maybe another 5 marks, on top of that, yeah? And if you produce your own Space Invaders from scratch using the techniques I've shown you, then you can get the full 15, yeah? So, I like these Headfirst JavaScript programming books. Headfirst, there's that, and the Headfirst JavaScript, there's a Headfirst HTML programming as well, right? They're nice books, but they're a bit out of date. But the chapters 10 and 11 have some good stuff on functions and flexible functions, and, I took some of the material from them, yeah. Modern JavaScript tutorial's got a nice stuff on classes, which is the more modern approach to using objects. I think this probably has prototypes in this book here, but this is some proper stuff on how classes work. I like this tutorial. And then they've got how modules work in JavaScript. And they've also got a nice Ninja code section that's worth a read. It's an ironical sort of take on the kinds of things that JavaScript programmers write that are extremely bad. Yeah, so it shows you all the bad practices that people perceive to be good practices, if you see what I mean. People think they're sort of super hard and cool and ninjas because they, make everything really obscure and difficult to maintain. And so it's a kind of satirical take on those kind of people. So don't be a ninja coder in the way that's described in this article. Yeah. Okay, so in this lecture I've been covering some of the advanced features of JavaScript. JavaScript, I think, apart from the this in classes, is a beautiful language. Yeah, I really like writing JavaScript. It's fun to write, and if you follow, if you use strict mode, if you use classes, if you use modules, then you can write code that's, robust and maintainable. Yeah, and particularly when it comes to server-side JavaScript as well, you're going to be writing a lot of this stuff, and so the sooner you learn to write good JavaScript, the better, because it's going to make your life a whole heap easier, I can tell you. Yeah. It's going to be much easier to build larger JavaScript projects with less errors if you do it using some of these techniques. So I strongly recommend that you incorporate advanced JavaScript features into your code.